Hey, Kiasi. So we're going to go over your practice test you're saying you need help with. Please do follow along. Some of these, I can see they're just minor little errors that hopefully this will help clear up. Some of them you need a little help on, I can tell, like the inverse function or finding the composition of functions, like f of x or and of g of x, where they're intertwined, that kind of thing. So please follow along. I'm going to tell you which numbers we're going on, and please take notes. Thank you. All right. So we're doing number one first, where it says factor the polynomial. Number one, and that is factoring the polynomial x cubed minus 27. So to take out of this, we have to take something out of both of these that it's going to factor into our answer choices. Now, this is one of the ones where I think it was just a minor slip up on your part because the answer choice you chose was x minus 3 times x squared minus 3x minus 9. I believe you factored it and you simply just switched the signs in your head. But the way I would go about solving this one is to actually work from the answer choices towards the answer. By that I mean go simply down the list of answer choices and find out which one of those gives me this answer. And the one we should be using, the answer here, was actually the first one, which was x minus 3 times x squared plus 3x plus 9. Well, you can say, well, how do I know that? Well, we know that because we can work this out now. We can multiply x minus 3 times x squared plus 3x plus 9, and we'll get this answer. So let's do that by doing a Punnett square, a 3 by 2 Punnett square, because that's the number of polynomials we have. So x minus 3 on this side, x squared plus 3x. Let me zoom in here for you. There we go. That's probably a lot better. And then plus 9. So x squared times x, that's going to be x cubed because we add on the exponents. So we have a 1 here plus the 2 here gives me a 3. We have x times 3x, which is going to give us 3x squared. We have x squared times negative 3, which will give us negative 3x squared. Here we have 3x times negative 3x, which will give me negative 9x. And here we have x times 9, which will give me 9x. And here we have negative 3 times positive 9, giving me negative 27. Now we're going to combine like terms. We don't have anything to combine with this x cubed. It is the only x cubed we have, so we bring it out. We have a 3x squared here, but we have a negative 3x squared here. In fact, we're done with that one. So we have a 3x squared here. We have a negative 3x squared here. Combining those will give us an answer of 0, so they're gone. We have a negative 9x here and a positive 9x here. So negative 9x plus 9x will give us 0, so they're gone, just like the 3x's, 3x squareds. And now we have negative 27, so we get x cubed minus 27, giving us our answer. So it should be the answer choice A, x minus 3 times x squared plus 3x plus 9. And that's how you do number one. Like I said, the one you had chosen, I think you had just messed up the signs. You had chosen the one where it was the negative 3x. Sorry, it was you chose the one where 3x was negative and 9 was negative. I think you just flipped the signs in your mind. So we're going to keep on going down here to number 4. That is find the composition of the function. Let me get a fresh piece of paper here. That is finding the composition sorry about my handwriting. It's a mix of cursive and print that I can't get rid of. And our function is f of g of x where f of x equals 2x plus 2 and g of x equals x over 2 minus 1. So we need to find this given these two values. And so we're dealing with our f of x and our g of x. So our g of x is inside of our f of x. So if we write this out, remember how this is going to work. If we're plugging in the g of x into our f of x function, meaning it looks like this, our g of x is inside our f of x, we take f of x, we take this 2x plus 2, okay? And instead of an x, we're going to put the g of x value. So instead of 2 of x plus 2, which is just 2 times g of x plus 2, that's really 2, and then what's our value for g of x? Times x over 2 minus 1 plus 2. So I hope that kind of better explains it. We have our f of x function, right? But we're plugging in our g of x function into here, giving us this here. And now that we have this, let's rewrite it down here, and then we'll work it out. So 2 times x over 2 minus 1 plus 2. Using PEMDAS, we got to start first with our parentheses. We have parentheses here, but we can't do anything inside of it. No exponents, so we're good there. So we got down to multiplication. This 2 needs to be multiplied by everything in here, so it needs to distribute. So let's do 2 times x over 2. That's going to give us a value. I'm trying to light here. Why my light not turn on? Oh, there we go. That helps a little bit. So I hope that helps. I can't really see on the screen. Okay, that looks okay. So multiplying across here, we get 2x over 2 for our value here now. And we'll rewrite this over here. Take our 2 times our negative 1, giving us a negative 2, and then plus 2. Combine like terms. What's negative 2 plus 2? Should be a 0, right? Or rather 2 minus 2 gives us still 0. Cancels out, leaving us with the value of 2x over 2. And we simplify this fraction. We simply get a value of x, which is our answer choice. You had chosen x minus 2. I think you got confused with this fraction here and what to do. So remember, we plugged in our function, and then we simply distributed to give us this value here of 2x over 2 minus 2 plus 2. Combine like terms, negative 2 plus 2 gives us 0, right? Because we pull out the number line here. And let's say here's 0. And we're at negative 2, right? So 1, 2. So if we're at negative 2 and we're adding 2, which way do we go, left or right? We go right. We're adding 2. So we go 1, 2, we end up at 0. Once we did that, all we were left with was this fraction of 2x over 2, giving us a value of x. I know these composition of function ones can be a little weird because of how you have to plug things in. So I hope this kind of explains that process a little better. If you need more help on it, we can do some more practice and just go over that lesson in the unit. So that's number 4. Let me get to the next one here. There was a number 5 was actually asking about inverses of functions, but not in solving one. It was the graph one, where it simply asked, I can zoom out here now. Oops, wrong button. Where it simply asked, is the inverse of this function a function? And it graphed out this here, almost like a tangent, but actually not. At 2, and it hits at right about here at negative 1, and again at 1, and then it comes up at 3. Kind of looks something like this. Maybe remember it. something like that, and it asks us, is this a function? Or rather, is the inverse a function? Oh, sorry. Give me 1 second. I have a student needing something reset. I'm so sorry about this. Alrighty. Ah. So if you remember an inverse, the x values become y and the y values become x. And to test for a function, we have the line test, right? So let's see here. So with our line test, it's the vertical line test to determine a function. So in an inverse, we have to determine what is that going to do to this graph. Now, like I said, inverses, I'm so sorry. I'm so sorry, man. Give me 1 minute. Okay. So now Ross said, okay, back to this. It actually tells us also apply the horizontal or vertical line test to determine if the inverse is a function or not. So if you remember the horizontal and vertical line tests, we have our original here. And does this pass the vertical line test? If I draw a vertical line anywhere on this graph, is it going to hit more than once? What do you think? Well, let's see. Well, it hits here, right? Hits there, but doesn't hit anywhere else. Well, maybe that was just a fluke. Let's pull a different color and try somewhere else. Let's try here. Well, it hits here, but that's about it, right? So this does pass the vertical line test. Oh, kind of slant line test here. But does it pass the horizontal line test? Well, it hits here, right? And it hits here, and it hits here. So it hits in 3 different parts going across here. So it actually is not a function. The inverse would also not be a function because of that. So the answer choice for this one actually should be no. This is not a function. That's number 5, inverse functions. Leading us into number 6, where we're actually needing to calculate an inverse function. So number 6 asks us to find the inverse function. And that function they gave us was y equals 5x minus 10. So if you remember from your lesson, the first step to finding an inverse of a function mathematically like this is you're going to want to turn all our y's into x's and all our x's into y's. How do we do that? Well, we simply just redraw it out and literally do that. So our y's will become an x's and our x's become y's. And now from here, we simply solve for y, getting y alone algebraically. So we have to determine everything over here that's not y, and we want to get it over to this side. So over here, the first thing we have is this negative 10. That's kind of detached from the 5y. We want to get rid of it. So we got to do the opposite of what's happening. So says the laws of algebra. So we have minus 10 here. So we have to do the opposite of subtraction, which is addition. So we're going to add 10 to both sides. Negative 10 plus 10 will cancel out, giving us 0. And over here, we now have x plus 10 equals 5y. From there, we now have to get rid of this here. We have to now get the y alone still. So everything there besides the y is just what? What else is there besides the y? Well, that 5, right? That 5 is there. And so we have to now get rid of that 5 by doing the opposite of what it's doing. And because that 5 is multiplying against the y, what are we going to do to get rid of it? That's right, we're going to divide. So we need to divide both sides by what value? By 5, right? So divide both sides by 5. This cancels out. 5 over 5 becomes 1, leaving us with the value of y just like we wanted. And now over here, the answer choice is a little bit different because there's a mathematical law that states if the numerator is as adding and it has the same denominator, like in this case we have a something plus something over one single number, we can actually split that up to be two separate fractions with the same denominator. So all we did there was simply take those two numbers and split them apart because they were being divided by the same number, but we can simply split them apart, giving us this here. And now we simply simplify because our y is alone. Now we're just going to simplify the terms. X over 5 stays the same. There's nothing we can do about that. But now we get 10 divided by 5, giving us 2 equals y. And now we have our answer. The inverse of the function y equals 5x minus 10 is y equals x over 5 plus 2. Oops, give me a second. The next one I saw you missed was the number 10, so get on down there. Asking us to find domain and range of a function. So it gives us a graph. Let me grab my ruler really quick. So number 10 gives us a graph. If you want to redraw it, you can. I'm just going to do a very simple sketch of it with the values needed. And it looks like our vertex is going to be at 2, hitting the y-axis at -4, and coming back down at 4, 4, about here. All right, mind my parabola. Our vertex. Alrighty, kind of gives us a rough graph of what we're dealing with here. And it asks us, find the domain and range. So if you remember from your lessons, the domain is all possible x values that our function will hit. So for all the values of our x-axis, which is this one here, right, that's our domain. So in this case, it hits our x-axis at 2, but the values of x continue on because this graph is going to continue sloping forever in either direction, meaning that our x values are always going to be increasing because here we're at 2x, right? But here on this line, we're at 3x. Like, so right here, our x value is 3, right? And right here, our x value, right, is 4. Our y value might be different, but our x value is increasing on both sides away from our vertex, right? So here it hits the x value at 1, here it hits the x value at 0, and here maybe hits at -1, -2, etc., etc. So it looks like eventually it's going to hit all the possible values along the x-axis. So in this case, our domain is going to equal infinity, actually, where x is less than or equal to infinity, but also less than or equal to negative infinity. Because, like I said, eventually this line is going to access all possible x values no matter which direction. That's why it's infinity on both sides. Now, if you remember, our range is equal to all of our possible y values. So on this graph here, we know our y-axis is up and down, right? So if we look here, we know our y values here are 0, right? And then it gets to -1, -2, -3, -4. We know it's going down, right, on both sides, but it's never going back up. So our actual range of y, we know it's going to hit all these negative numbers in the world. It's going to hit all of negative infinity, but it's never going to be greater than 0. So y is going to be less than or equal to 0, but it is also going to be greater than or equal to negative infinity. And that's why it's going to be these ones here, because eventually all of our x values, the domain is eventually going to hit all these x values. No matter how far I go, I can go on to 25,367,201. Eventually, there will be an x value that coordinates with this function. However, with the y, our range, it is never going to get bigger than 0, but it will always get smaller than 0 and hit all the negatives, which is why y is going to be less than 0, but greater than negative infinity. So that's number 10 there. I'll do a few more of these. I think our video capacity can take it. Number 19 is one I think you just got tripped up on because it is kind of a simplified, not simplified, but maybe maybe too easy to think maybe it's almost hard kind of thing. That's asking us to subtract the two polynomials. And that's asking us to subtract 5x minus 1 minus 3xy plus c. And so first thing we have to do is PEMDAS. If you remember PEMDAS, we got parentheses, exponents, multiplication, division, addition, subtraction, right? This is a very good mnemonic for the order of operations, the order in which we do our mathematical properties. So if you want to remember that, if you write it down, if you don't have it before, now you do. It's a very useful tool, and it's going to come in handy here. So first thing we're going to look at is our parentheses. Is there anything we can do in these parentheses? Anything we can add or subtract? There's not, right? 5x, our variable, can't subtract 1 from our variable. We can't add a c to our 3xy. So they're in the most simplified form. So the parentheses are done. So now we do our exponents. Are there any exponents that we got to deal with? No exponents. There actually is one thing we got to multiply, and it's actually a distribution of this negative sign here. Because remember, outside of all these parentheses, there's an invisible 1. So we have to pretty much multiply everything in here by that -1. So -1 times that. In fact, let's rewrite before we start. Our 5x minus 1 stays the same. -1 times -3xy turns it into -3xy. Sorry, positive. It turns into that. -1 times 3xy turns into -3xy. Our -1 times our c gives us a -c. And now we have this more simplified looking polynomial here. And now Multiply is done. Can we divide anything? No. Is there anything we can add? Are any of these values wholly the same? And I don't mean are there x's here and x's here, or are there y's here and y's somewhere else. I mean, do any of these numbers, any of these values, any of these variables have fully matching numbers or variables? No, right? The 5x, are there any other variables that just have an x on it? There's not. We have this negative 3xy, but because of that y, we can't combine these two. So there's nothing we can do about that. There's a negative 1, but there's no other whole numbers, so the negative 1 stays the same. Are there any other numbers in here or any of the values that have an x and a y? No, so the negative 3x, y stays the same. And is there any other c's in this equation? No, so the negative c stays the same. So our answer is actually this. This is all we can do. And that would be our answer. I think that one just kind of looked confusing, and I think I saw you tried to kind of combine things. So this is definitely how you would do it here. Just be careful about the order of operations and follow through, and you'll come to this answer here. That's number 19. The last one we're going to go over is synthetic division, and I hope I can before I run out of time on my video here. These do have a 30-minute timer. I'm sorry we've gone so for long, but this is quite a long practice test here. Number 23 is asking us to, that's not 3, number 23, is asking us to use synthetic division, which I'm not going to lie is a bit weird. So if it seems like a new concept, that's probably because you have never used it before. It is a fairly different concept from how you would do other things, but it can come in handy. So our synthetic division asks us to divide 1, negative 2, negative 23, and 60 divided by negative 5. So we first start off with our first value, 1. And that stays the same. The 1 stays as 1. You just bring that down. But now what we do is negative 5 times 1 is equal to what? What's negative 5 times 1? Negative 5. And so we put that here. And now we add these two values together, okay? So negative 2 minus 5 or plus negative 5 gives us negative 7. And then negative 5 times negative 7 equals what? Positive 35, right? Negative times a negative will give us a positive. That gives us negative 23 plus 35. That one probably can't do in your head. If you want to get a calculator, go ahead. That's going to be equal to 12. Negative 5 times 12 gives us negative 60. And 60 minus 60 is 0. So we end up with these numbers here, and now we're done. So now we have to convert those into x's. So we know this is going to be a trinomial, right? We got 3 values. Let's write those 3 values out. We have a 1, we have a negative 7, and we have a positive 12, so a plus 12, right? The 0 goes away because it's gone, so we don't even bring that down here. So we know we have a trinomial. We know the basic order of trinomials. You know, we have x squared and x and then a whole number. So in this case, we go from left to right. We have our x squared here, so this will be x squared. This here will be our x, and that'll be our whole number. And that's how you divide synthetically. So that's number 23. I believe that's the last one we're going to go over. Hope this video helped you, Ms. Walton. If you need more clarification on any of the methods we used or any of the questions or just different ways to do them or anything like that, feel free to text me, call me, email me, whatever you got to do. I'm here 24/7, so be sure to let me know how this helped. On that practice test, be careful about the inverses. Be sure to review and study for that. That seemed to be a part that you're having a little bit of trouble with. I can show you some different methods, I can give you some more steps or just something you can follow along with if you need that. So hope this helped, and have a great day.